Good evening all. It's great to see you all again. Hope you've been having a really, really good day. I know I certainly have. There's one frustration I have every year at SpringOne. Realized there were 45 technical sessions today, and I wanted to see all of them, and at the best you can only get to do 5. So every single slot there's 8 sessions you might want to see that you can't. Good news is they're all recorded, so you will be able to watch them when you get home. I did a little bit of a back of an envelope calculation, actually. I was wondering about that. It turns out that if you watch them full time, I'm assuming you're going to work about 40 hours a week, and you're going to work 5 days a week. It will only take you 4.5 weeks non-stop back-to-back to get through all of the content at the show. If you can't afford to stop full-time for 4.5 weeks, I understand, have an alternative plan for you. You could watch 1 session a day, an hour and a half each morning. That would take you about 6 months. That's when I realized why, with all this good intention I have to come and catch up on all the content, I never quite get all the way through. If you're wondering what to do with the other 6 months, there are over 50 task-focused guides on the new SpringIO website. So by the time you've got through watching the videos, I'm sure we'll have more. That might see you through the second half of the year. So just a ton of good content at the show. A few things I kind of picked up on today, just wandering around, dropping in the sessions, talking to people. Groovy's everywhere this year. It's kind of interesting just to spot that. I went into a packed, I was in a packed Grails session. We had to kind of coordinate ourselves and go get some extra chairs from next door and fill them up in the aisle so we could all get in. If you saw, obviously, Dave and Phil doing the boot session. I know many, many of you are clearly interested in that from last night because it was packed again in the theater there. You saw Groovy popping up there. You saw Jürgen talking about Groovy support coming in Spring Framework 4. Always a highlight of mine. Jürgen, kind of the ultimate authority, giving his wisdom on Java 8 and what you're going to encounter. I enjoyed that today. We had Reactor at the end. Ton of good stuff. Plenty more I didn't get to see, of course. I hope you're not exhausted from what you've heard, because we're far from done yet. We've got some more really, really good things I'm really excited for you to see tonight. You remember the SpringIO picture we were talking about yesterday. The I/O foundation, the cohesive version set of projects, and the execution layer on top. We focused pretty heavily in our keynote last night, and in today you've seen it on Spring Boot. It's kind of pulling a lot of that together. Tonight we're going to share with you the latest in the Grails world. So that's another one of our kind of domain-specific runtimes, the original, the project that was showing us the way there. And I'm delighted very shortly to bring Graeme up on stage to take you through that. Then we're going to put a little bit of a focus on the data side of the house. We're going to talk about some updates in the batch world, some of what's going on with a very exciting new project called SpringXD. I gave you a brief introduction to that tonight. You're going to see in a lot more detail what's been happening there. Some really interesting things in the world of data. If you're interested in some of this combination of sort of fast data and big data, sort of John and Stefan were talking about that in their Reactor talk. There's a talk tomorrow, I think, on sort of combining fast data and Hadoop. That's another good one to go to. So we have the remaining 4 dwarves, basically, tonight. Last night there were 3 dwarves. Tonight we have the remaining 4 dwarves to come and share their wisdom with you. And with no further ado, I'd like to invite to the stage Graeme Rocher, who can choose which dwarf he'd like to be.
Thank you. Cool. Excellent. So let's kick off this. OK, so we got the slides up. So as the first part of the rest of the dwarves, I'm super thrilled to talk to you about Grails as one of the DSR domain-specific runtimes in the SpringIO stack. We are really excited to present this vision of a cohesive ecosystem for SpringIO, and Grails being one of the DSRs in that stack, and also with Groovy being such a key component in the core foundation of SpringIO. So let me start a little bit first about Groovy. So Groovy Groovy, as you've seen, as Adrian said, it's absolutely everywhere at this conference. We're super thrilled to see that. It's been featured in projects in a diverse range of use cases, from Spring Boot to the Project Reactor, which there was a super exciting, completely packed out talk on Project Reactor, which showed some really compelling examples of doing highly asynchronous applications. Spring Boot to get your Spring applications configured automatically in an opinionated way. And again, Groovy playing a key part in making that possible. So Groovy is really a deep part of the Spring I/O foundation. And it's also pretty thrilling for this all to be happening on the 10th anniversary of the Groovy language. Happy birthday, Groovy. So for those of you who are not familiar with Groovy, and is there anybody in this audience not familiar with Groovy? Well, a few hands. Well, anyway, there's some great talks. There's some related sessions. There's Groovy for Spring Java developers, which is tomorrow. If you want to check that out, go ahead and attend that session, and there'll be some great intro material there. And in terms of Groovy, what's coming up, and the Groovy 2.2 release is on the horizon, and there's some super exciting stuff in there coming up, particularly with the integration in terms of with Spring 4. There's some features that just make Groovy nicer to work with. It's not a big bang release, but there's some nice subtle changes. Closure coercion to align it closer to Java 8. So when you have an interface and it has a single method, those get automatically coerced. Closures get automatically coerced into interfaces. And some little nice touches like a memwise transformation for method calls as well. So super exciting stuff coming up in Groovy 2.2. And if you want to see what Groovy is capable of, check out the Creating Groovy DSLs that developers can use talk tomorrow as well. So now let's move on to Grails. So Grails is, as I said, a key part of the Spring I/O execution layer. And it's the full-stack web development framework as part of Spring I/O. And it's built on those foundational blocks, built on the Spring framework, built on the Groovy language. And it features integration with key Spring I/O pieces like Spring Security, Reactor, and so on. And in terms of what exciting news to announce today, yesterday we released the 2.3 GA version of Grails. So we have some extremely exciting features there. I guess, so for those that came to my talk earlier, you'll probably already be familiar with them. But there's some pretty compelling new features in this release. We have got complete, refined server-side REST support. It was always possible and doable and nice to build REST services with Grails, but now it's even better with REST scaffolding, higher-level constructs for exposing domain classes as REST services, the ability to do so asynchronously, asynchronous programming APIs, low-level primitive async APIs such as promises, automatic cross-site scripting prevention. So no longer do you have to make sure that each individual variable in your GSPs is escaped. We have a comprehensive cross-site scripting prevention engine built into GSP that has double encoding prevention, so you cannot double encode data. It tracks every piece that you render. If it gets encoded once, there's no chance it can be encoded again. You have to explicitly mark data that you want to be not escaped using an explicit method call. Grails is a lot more secure from it in 2.3. And we got new data binding APIs that can automatically bind JSON and XML packets directly into domain classes, command objects. And and completely rewritten to be aware of the domain model. So again, another exciting feature in terms linked very closely to the REST support. We've also got forked execution and a test running daemon. So everything in Grails has been isolated from each other. When you run the application, it's forked into a separate Java virtual machine. When you run the test, it's forked into a separate Java virtual machine. And to make that all feel responsive and speedy, because when you spin up a new JVM, there's a cost associated that we have a daemon that will run constantly in the background and speed up your test execution. We've also got brand new dependency resolution engine that has replaced Ivy based on Ether. For those of you who are not familiar with Ether, Ether is the dependency resolution engine that is part of the Maven build tool. It has been extracted into a separate independent project, and it has now been embedded into Grails as the dependency resolution engine. What does that get you? Well, basically, it means that you get the same dependency resolution semantics as the Maven build tool, which is frankly what most people expect. So in terms of snapshot handling, using the same local repository, just superior Maven integration. So a lot of really cool stuff being announced with Grails 2.3. And another thing that I have to announce today is we have a milestone release of the Graeme for REST plugin. So what is Graeme for REST? Graeme for REST allows you to use Graeme-like methods to call REST services. Yeah, it's fully asynchronous, so you can call those methods in an asynchronous, non-blocking fashion, as you normally want to do when invoking an external REST web service. And it integrates absolutely seamlessly into the server-side REST support that is part of Grails 2.3. And to see that all put together in action, I'm going to do a brief demo of Grails 2.3 and the Graeme for REST plugin to show you exactly how that all links and works together nicely. I'm going to go up to the other laptop. Okie dokie. Okay, so we got it up here. So I have a Grails application that I created beforehand. And what I'm going to do is just create a domain class. So domain classes in Grails are essentially your kind of business entities or whatever you want to call them. So I'm going to create one called book. And then I'm going to open that guy up. And this is my domain class here. So what I'm going to do is add a couple of properties and keep it simple for the moment. And the next thing I'm going to do is I'm going to import the Grails.rest package. And I'm going to annotate this with the @resource annotation. And what this does is it marks this domain class as a REST resource. Yeah? You can also tell Grails which formats you want to expose. So in this case, I'm going to say I want to do JSON and XML. Yeah? So that configures my domain class as a REST resource. Now, typically, with the REST resources, you want to map them to a particular URI. And you can do that, as with there in Grails, inside the URL mappings.groovy file. So what I'm going to do is I'm going to define a books URI that maps to the book resource, or resources, because there's many of them, right? And I'm going to save that off. So now, now I can essentially just spin up my application using Grails run app. And if we go to a browser, for the moment, just to try it out, you'll notice that when I refresh this page, my application is up and running, we get a just an empty array because I don't have any data. If we actually look at what's coming out from that inside curl, so if I do curl/I and then my URL, you can see that I've got application/JSON coming back, yeah? So that's my REST resource exposed and available. So I'm just getting an empty array. So now I could start sending post requests and to create data and so on using curl and fiddling around with the command line. But now that we have Gorm for REST, it seems so much easier to create a client for this, right? So I kind of created one beforehand, and I've got it set up in the Groovy console. So basically, I've got another application, a completely separate Grails application, and this is called the client application. And again, we got the same domain class. The only difference here is that it has a mapping, and it accepts JSON, and it's mapped to this specific endpoint. Now, I've kind of hard-coded the URL in there, but you can split that out into a separate configuration, and you can instead specify URI or whatever, so that you don't have those kind of values hard-coded into your domain class. But anyway, for the purposes of this demo, I've just put the full URL in there. It's very flexible in terms of the plugin. You can configure whatever you want. So now, if I come back to my console and import my client, and I do book.list, so I get no results back, right? Because there's nothing created yet. If I create a new book, title, stand, author, Stephen King. Let's go on to a new line here so we can fit this all in. Pages, 1,200 probably. Never ending. That's a really long book. Has anybody read that book? It's like forever. Anyway, so yeah, I'm going to save one of these guys. So if I save this, there we go. We've created my first book. Now, if I go back to my curl UI here, we can see that there it is. It's been created. It's exposed in my REST service. If I use the ID to get the individual one, we can get the individual domain class using curl. You can see we've got my application JSON back and so on. So I can create another one of these. The Shining or whatever. I think that one was probably a little bit shorter. Don't remember exactly, but not really important. So now we've got two of them, and we can list all of these guys. You can say book.list.each and print line it.title, print line it.pages. There we go. Run that. You see, there we go. It's listing all of those books. In the background is issuing a REST request to get that JSON data back, parse it, turn it into my domain model, and display it. All very simple. We can get an individual book. Yeah, so just by doing get, there we go. There's my individual book. We can read a book back. So get hold of a book, and then maybe we got the page count wrong before, and it really is like 2,500 pages or something. We can modify that and then save this guy, and that'll do a put request to basically update my book. So now if I get it back and print the number, we'll just get the number of pages so we can verify that, yeah, it's updated. And then if we get ready, just give up counting the number of pages, we can delete the book because we no longer. And then of course, when we list them back, there's only so many of them. There's one of them again. So that's all pretty cool. But so you get like a kind of full Gorm API I'm just going to reinstate one of my books. That's why I'm going back here. Yeah, OK, we're going to run that again. So we get 3. So we've got a full Gorm API, very Gorm-like API, onto our REST web service. Yeah? So we've got the client and the server going back and forth. All pretty cool stuff, no? But now all of these calls are synchronous. And that's not really what you want. So one of the another great features of Grails 2.3 is we have all these async programming APIs integrated in there. So we have some really neat async primitives. And one of the things you can do, so I'm going to import the Grails.async package. And we have what we're calling Gorm async. And what you can basically do is say, I can get the first book. And we have these building blocks for async. So one of the building blocks is a promise list. So I can say book.list, book.async.get. Yeah? So I'm using the async namespace. And instead of doing the call synchronously, it's going to return a promise, and I'm going to add a couple of calls. So I think my other ID was 3. So that's 2 asynchronous calls that are combined into like a list of promises. And then you can wait for those to all complete. And when you get the results back, we can iterate over them and see what we get. So printline b.title, printline b pages. And I'm going to return down here because otherwise, because this is happening async, it's going to end up printing out the promise, which is not really what we want. So when we run that, there you go. So this is Gorm for async, basically. Completely asynchronous REST client. Yeah? So that's my demo. I hope you enjoyed that. So I'm going to go back over here to the slide deck. And I'm going to call up Michael Minella, who's going to take you through the next part of Spring IO Foundation, which is Spring Batch. So welcome. Thanks, guys.
Spring Batch. So this is an exciting time for batch processing. Typically, batch processing has been the boring stuff that nobody likes to talk about. It's always stuck in the back corner. The guys that work on it are associated with being grumpy. I don't think I'm grumpy. But like I said, this is an exciting time for batch processing. With the JSR 352 coming out, also batch processing is getting kind of a new renewal with big data. I want to talk a little bit about the JSR, where we're at with the JSR, and then I'll give a little demo with what's going on. So JSR 352 is the batch JSR. The idea behind it is to provide a standard API for batch processing in Java. Spring likes to think we know a little bit about batch processing. And so we got involved in this JSR. We contributed a quarter of the expert group, myself and Wayne Lund, and we collaborated with all these experts about best ways to handle batch processing. And I'll show you in a minute what we came up with. But let me give you a little status on where we're at. Right now, as of last night, Spring Batch 3.0.0 milestone 1 was released. It passes 50% of the JSR test or TCK. So I'm really excited about that. When we release 3.0 later this year, we will be JSR 352 compliant. Like I said, we spent a number of hours with the community, with experts, talking about the best way to build batch applications. The expert group was comprised of people from all different corporations, all different experiences. And what did we come up with? On the right is the spec. On the left is our documentation. Section 7, in fact, of the spec, if you take out Spring Batch and replace it with JSR 352, you get our documentation word for word. Structurally, they're exactly the same. But I want you to take note that JSR 352 is not a drop-in replacement for Spring Batch. And the best way for me to illustrate that is with a demo. So my demo, I want you to think back to the year 2003, 10 years ago. Spring was new. A 30 gig iPod cost $500. Mark Zuckerberg was back in college still, and YouTube didn't exist yet. Yet a couple kids in their basement filmed this video. But so like I said, think back to 2003. When this video was posted, YouTube didn't exist yet, and yet this video within the first 2 weeks was downloaded 1.1 million times. Back then, that was big news. So I was curious, who was downloading this video? And fortunately, in 2008, the person that owned the website posted the Apache logs for anybody to look at. So I downloaded them and took a look. Let's take a look at them really quick. So if you're familiar with Apache logs, there's nothing surprising here. You've got an IP address, a date, the URLs are requested, status code, all that type of stuff. But back in 2003, analyzing this stuff really was out of reach, right? Nobody was doing any of this type of analysis, or if they were, it was very, very limited. Nowadays, this has actually become much more simple. So the batch job I'm going to create for the JSR is actually going to look through this data, and we're going to determine who's watching this video. Is it us goofy Americans that are the only ones that are interested in this, or is this a worldwide thing? So I've created a batch job. Using the JSR's API. You'll see the configuration, the actual XML, isn't that different from any other batch job. The JSR still, like I said, is structurally the same, so it still has a job. It has multiple steps. Within the steps, you can execute either a batchlet, which is a single executable class, or you can do chunking with readers, writers, and processors. So all the same paradigms that we have in Spring Batch still apply in the JSR world. We even have the same type of error handling. In this case, I've configured this job to skip exceptions when they occur. My regular expressions aren't perfect, so I figured just skip them. When we run this, I hope so, in the right window. Why am I not able to see the whole thing? Cool, build success. So I'm going to run this job. Really, I'm just running the jar file. Log analysis is the name of the file that the job is in. One of the interesting things with the JSR is it goes by the file name instead of the job name. But so when I run this, it's going to process a whole bunch of records, blah, blah, blah. Finishes. And then the report I'm generating is actually this. If I could resize it so it all fits. But essentially, it's a map of the world colored so that you can actually see that this really is an American problem, and we're the ones watching these goofy videos. But some notes about that batch job I just ran. Custom code. So the XML, there isn't a lot of XML when you compare it to batch jobs. I mean, it's just the job definition. There really is no other XML here. But on the custom code side, there's over 800 lines of custom code. I had to write my own reader. I had to write my own writer. There's a couple batchlets in here. There's parsing involved. All that's custom code. If I go to the Spring Batch side, yes, I have more XML. This is the exact same batch job. It does the exact same thing. But instead of taking over 800 lines of code, it takes a little less than 500 lines of code. All of the pieces I need are already provided. So instead of me writing my own batchlet to split the file, I use a system command tasklet. That's readily available in the framework. I use The multi-resource item reader that's available in the framework for my reading. I use the JDBC batch item writer for writing. All these components are available from the framework that are not provided with the JSR. Like I said, JSR 352 is not a drop-in replacement. There are many features within Spring Batch that go beyond the JSR. The JSR provides 3 specific things: an API for building batch artifacts, a DSL for configuring them, and a contract for how they interact. It doesn't provide any of the actual components that you're used to using. No readers, no writers, etc. Spring Batch also goes beyond the JSR. We provide implementations of things that the JSR includes, like readers and writers, but we also provide things like configuration options. The JSR is XML only. We provide builders via the Java API that Dave Sire was talking about yesterday. And we provide scalability options. The JSR is single JVM only. The only way to scale your batch applications are via threads, whereas within Spring Batch we have remote chunking and remote partitioning, where you can scale out across multiple servers or even in the cloud. The integration options, those scalability options, use those, as well as we have other integration options that allow things like executing jobs via messages. So this is where we're at. Like I said, Spring Batch 3.0.0 milestone 2 was released last night. It's available. We look forward to your feedback. And it'll be GA later this year. With that, it is my honor and privilege to introduce Mark Fisher, my boss.
Okay, so one question that's been plaguing me ever since Adrian's first introduction last night is, am I dopey? Or am I grumpy? But I think most of us know that there are 2 candidates for grumpy. One of them seemed to have changed into happy last night. The other problem is that those same 2 candidates also have PhDs, and someone has to be doc. So I'll let you decide whether I'm grumpy or dopey based on how my demo goes here tonight. Okay, for the rest of the keynote, we're going to be talking about big data and why it's important to enterprise developers like yourselves, and what we on the Spring team are doing to make your life easier. So first, we'll talk about some of the motivations for big data applications. Enterprises can store and analyze more data than ever before. There's a cost angle here and a technology angle. On the cost side, everyone knows physical storage costs have decreased gradually for years now. But also, as Paul Moritz mentioned last night, living in the cloud computing era, infrastructure as a service is now the new hardware. Platform as a service is the new operating system. That has technology consequences, obviously, allowing us to actually scale resources on demand. But it also has a cost angle where operational costs are reduced in addition to the physical costs. And then finally, there is a software ecosystem, increasingly open source software offerings. If you look at Hadoop, probably the first thing that comes to most people's mind around big data, and its distributed file system, HDFS. That is open source software that you can run on commodity hardware that allows you to scale for storage and for processing. So these are all important trends. Some other trends that are happening now that this technology is available on the side of use cases, I've listed a few categories here. But what's interesting, I think, is the trends behind these use cases. One of those is gathering more data from your users. So on the customer retention side, that's important for targeted advertising. It's important for customer sentiment. And I think probably most people have heard of a well-known travel website that was displaying more expensive hotel options to Mac users. Obviously, they're correlating on the user agent field that they're gathering. So they're not just tracking what hotels you're searching for, what purchases you're making, and your basic history. They're actually looking at much more of the information. They're gathering that, and they're doing analysis on that and coming up with these patterns. Likewise, tapping into social networks, which is important for recommendation engines, also for the customer sentiment. If someone has 50,000 followers, then you want that to be a happy customer. If someone has 3 followers, maybe you don't care so much. And you're starting to see this in real-world use cases. Risk assessment is an interesting one. From the insurance perspective, I think it's an industry that's literally being revolutionized by big data. By being able to actually track information about your driving habits, it changes the risk model that is used there. And similarly, or I should say additionally, in addition to gathering more data and traversing social networks, there's also just more data being generated by machines, more data being generated by sensors and smart technologies. And so that leads to this research study from IDC that was commissioned by EMC in 2012, where it shows the increase in the percentage of the big data footprint, or the data universe footprint, that is comprised of machine-generated data. And you can see here in 2005, well, you might not be able to see, but I'll tell you, the first box there from 2005 says 11%. So basically, not very much machine-generated data. Today, 2013, it's up to a third, 33%. And by 2020, this estimates 42% of the data being generated by machines instead of humans. But also interesting in the same study is the amount of overall data. So machine-generated data is a larger piece of the pie, but the pie itself is growing even more than that. The amount of exabytes of data, so an exabyte is 1 billion gigabytes, and there are 4,000 exabytes of data in this data footprint today, roughly 4,000, I think between 4,000 and 5,000. And that's expected to grow to 40,000 exabytes by 2020. So that means the pie itself is growing tenfold. And what that actually means is that there will be, I think, 4 to 5 times more machine-generated data in 10 years than there is today in human-generated data. And so this shows actually the numbers here, 7.6 billion people in 2020, 200 billion things. And importantly, that does not include tags and sensors, of which number in the trillions. Okay, so assuming that this is convincing and that big data is something that we should be concerned about, then what are the challenges that we face as developers? First of all, there are multiple domains to big data. If you're building a comprehensive big data application, you're going to need to ingest data. You probably need to do some kind of real-time processing of the streams of data that you're ingesting. You need to export data and integrate with legacy systems, internal systems as well as external systems, and social networks. And you need to be able to do batch processing as well. And so this is a relatively young space, and there's a lot of really good software out there, but the APIs tend to focus on one of those domains at a time. Some API library that focuses on data ingestion. And it may do that really well, but the configuration for that library is going to be different than the configuration you're using for batch processing and so on. So you end up having to do a lot of gluing of these things together, writing scripts and so on. The APIs are inconsistent. And a lot of them are not that mature. It's interesting that if you look at some of these APIs for dealing with big data storage, it looks similar to the typical JDBC code we saw 10 years ago when Spring came onto the scene and provided JDBC template. Right? You've got resource management, thread safety issues with the resources themselves. You've got exceptions that need to be caught at multiple levels, sometimes nested inside each other. And when you look at code like this as a Spring developer, someone who's been working with Spring for years, and you see those patterns, it's like deja vu, right? And so obviously we've recognized that, and we're aiming to do what we can to solve those problems. And importantly, I think if you look at these different domains, the most important thing that we can do is actually provide a unified model that allows you to work across those domains. And what we recognize is that there are patterns that are needed to solve these problems that are actually very similar to patterns that we've been solving for several years. Both Spring Integration and Spring Batch started in 2007. And it's not listed here on the slide, but both of those projects also integrate heavily with all of our Spring data offerings. And today, they're both also integrated within Spring for Apache Hadoop. So these are at the foundational level from our I/O diagram, tackling the problems of real-time ingestion and stream processing, where the enterprise integration patterns that are supported by Spring integration can handle a lot of those problems with our channel adapters, the message channels themselves to decouple the processing steps, filters, transformers, and so on. And then obviously, Spring Batch can be used to manage the workflow of jobs, multiple jobs with restart capability, being able to coordinate jobs that run multiple steps. And this will look familiar to anyone who was at SpringOne last year. This was the demo that Mark Pollack showed. It was focused on the tweets about the election. It just happened to be a few weeks before the election last year, so that was a pretty relevant topic. We were grabbing tweets about Romney, Obama, and Justin Bieber as the kind of control group. And then we were counting the hashtags to see how many each of them were being mentioned in these tweets. We were storing to Hadoop and Splunk, and then kicking off batch processing on that to do a similar analysis of the hashtags so we could show the historical view compared to the recent view off of Redis. And then we displayed all of that in a tag cloud in the UI. In a few moments, when Mark comes up, you're going to see a revised version of this built with Spring XD. And before we do that, I just want to give a quick introduction to Spring XD itself. So the features of Spring XD, basically we're trying to handle these problems, these big data challenges that I just mentioned. So we want to have a unified platform. Your stream processing and your batch processing run on the same system. We want developer productivity, so we have not only what you typically expect from Spring, but we're taking it up another level so that you have a DSL that you can work with. You'll see in just a moment. It's modular and extensible, meaning that there are a number of modules out of the box, but if you want to add your own, it's just a matter of knowing some basic Spring configuration and being able to drop those into the runtime. It's a distributed architecture, which is important because these types of applications need to scale. So you can run, we always want to keep things simple as possible for the developer when you're writing your code and testing it. So we do have a standalone single node environment, but we also have everything from a simple cluster where you simply start and manage multiple JVMs yourself to a runtime mechanism that is portable, so you can run on top of Yarn on Hadoop, for instance, and other environments that Mark will talk about in a few moments. It also works with any of the popular Hadoop distributions behind the scenes, really hiding that from the developer, so that's your choice, and we're testing against those as well. And it's built on the foundation of Spring technologies. And this is really a logical architecture, showing, I think what's most important is that everything you see on the edges is pluggable. So we have a number of different input sources, we have a number of different data syncs, and those are extensible. So those will continue to grow, and you'll be able to add your own. We support a number of different options right now, Redis and Gemfire, as well as in-memory for doing some basic analytics, but that's also something that will be extended considerably. And you see here at the top that we have streams and jobs, and there's a channel between them. And this is something, if anyone attended Michael and Gunnar's talk earlier today with Spring Batch and integration, you saw how those two projects actually work together really well. You can launch jobs by sending messages. You can listen to messages from job execution state. And we're incorporating that directly within Spring XD, building on top of the assets that were in the Spring Batch admin project and evolving that Spring Batch admin project as part of the XD effort as well. And then we have a shell, which is actually interacting with a REST API. On the stream processing side, we're using Spring integration. So you have these modules in between channels. With Spring integration, we have always tried to make it as simple as it could be. We have XML namespaces that hide most of the details, and here you're defining these components. Kind of like Dave said last night, that an XML is a fine representation for a state machine. It also seems to work really well for defining these declarative components that make up your pipeline. And so we tried to make it as simple as possible. And this doesn't look that bad, but it's still code and configuration that you would be managing as a developer. And so we've thought about this quite a bit. How can we make this easier? And we even showed a preview of it last year, thinking in terms of pipes and filters, Unix pipes and filters. So these are the modules, and then the pipe is an abstraction that's actually backed by a message channel. And with XD, what you see here is actually an excerpt of an interaction in the shell, where we've defined a stream that's reading from HTTP, it's filtering with a spell expression, and then writing to a file. And that is literally all you have to provide. Behind the scenes, those tokens are being mapped to modules that exist in a registry that are using Spring integration configuration. And if you want to add your own, you can drop those in. But this shows the creation of a stream, posting data to a stream, and then displaying the result. And with that, I'm going to go into a demo and show you something similar. OK, so what I'm going to do is I'm going to start XD in single node mode. And I'm going to use Redis for analytics. This would be in memory by default if I'm using single node mode. And then I'm going to create a simple stream. Oh, first I should mention, well, I got to run the shell. Sorry. I'm doing this too much. OK, so the XD shell starts up, some nice ASCII art. And I can hit tab and see what commands are available. I want to create a stream, so I'm going to try stream and then tab again, and I see what stream commands are available. I need to create a stream, so I create a stream, call it tick-tock. We have a source called time that just emits the time by default every second, and I'm going to write that to the log. And then it's actually logging in the XD single node instance that's running there at the bottom half of the screen. And you can see every second. If I do a stream list, I see tick-tock. It's deployed. I can do a stream undeploy. Name. Undeploys. The logging stops. And I can redeploy, not destroy. And the logging picks back up again. Okay? And then I'm going to destroy that so that I don't see it. Okay. And now I want to create a different stream. We'll do dwarfs. HTTP to file. And the Spring shell is extensible, so there are different jars that you can drop in. You can write your own. We have HTTP support in here. We have Hadoop support that Mark's going to show next, built into the shell itself. And this allows me to do some basic posting of data. So I can say, who do we have? Doc. OK. And then I can actually shell out here with an exclamation point and show the default location where this has been written. Is there, and we see doc in the file. And now what I want to do is show you just a little bit of stream processing. So that's kind of covering ingestion. You can create a stream. Every time you create a stream, everywhere there's a pipe, there's also a channel. And those channels can be used as taps. Every channel is basically wiretapped. And if you need to plug in and do something on the data in real time, you can do that with a tap. So we'll call this count. And what I'll do is start with tap on dwarves. And send that to a counter. OK? And now I can do counter list and see. It's not there yet because I haven't posted any data. Let me post another dwarf. Grumpy. OK. And then counter list, I see count, counter display, What's wrong? Oh, sorry. I wasn't noticing that here. Okay. Counter display, name, count. And we see there's 1. I can post another dwarf. Really? Sorry. Do you see that? I'm sorry. Okay. 2, and so on. You can add an aggregate counter, which is interesting. Let's go back to the, also you can see I've got up arrow support. Do ag count, and we'll change this to aggregate counter. And post a couple more dwarves. Sleepy and sneezy. Perhaps I'm sneezy. I sneezed when I was checking in, and the person at the desk said, "That's weird, you only sneezed once." So I almost sneezed again when she said that. Okay, aggregate counter display, ag count. You can see the 2 that I sent just then. And I just want to show one last thing, which is this is using Redis, as I mentioned. So we look at the keys. And the way that the aggregate counter works is it's actually putting the counts within the buckets from year, month, and day and hour. So there's a lot you can do with that, and this is an extension point. We plan on adding a lot of other support. We also have rich gauges that do averages and so on. And you're going to see a lot of this if you go to Luke and David's talk tomorrow, Real-Time Analytics with Spring, and they have much nicer visualization than me, and more than you see from the shell. So with that, I'll introduce Mark Pollack to finish the keynote here by reviving last year's demo on XD. Thank you.
So what I'm going to do today is redo very quickly the demo from last year, showing you how quickly we can create applications using XD instead of writing code, instead really just configuring an existing runtime. So what you have here is really what I'll show in the shell. Instead of writing a lot of applications in Spring Hadoop, Batch, Spring Integration, and I just now have to basically type 4 lines into the shell to create the equivalent application. Let me pop into my friendly VM here. Oops. OK, so here I have the shell, the Spring XD, running. Here I have an instance of a single node running as well. I can show the command I used to start that. It should be up here somewhere. Where is it? Not scrolling very well. Anyway, it's running. I picked Hadoop 2.0 as the distribution. I'm using analytics with Redis and the single node, so it's a local transport. So what I can do is, I just tap them all in. I'm going to create a Twitter search. So that's one of the sources we have. I'm going to query for Obama, Romney, or Bieber. I'm going to convert this to JSON and just pump it into a file. So I'll create a new stream. So I can do stream list. Now you see it's deployed. I don't like to type, so I have these in the history. So now I'll create a tap on this stream. So this tap, I'm going to filter using a spell expression. This is a processing module inside of XD. Spell expressions are handy, of course, for just doing very simple one-liner kind of things. But we support Groovy as processing modules, as well as Java as processing modules. And I'm piping this into an aggregate counter and calling it Obama count. So that's the counter for Obama. Oops. Go over here. Do the same for Romney. And do the same for our very good friend Justin Bieber. So these are running right now. And if I pop into the UI from last year, not that, this over here, Twitter search, I was running it before. you see these ticks starting to go up a little bit. It's 14. And looking into this, running it, apparently tonight there's a big speech by Obama on Syria. So I guess it's a healthy sign of our country that finally, something worthwhile discussing is beating out the new mustache that Justin Bieber apparently showed today at the fashion show in New York. And this aggregate counter is what's feeding basically the last 15 minutes, last hour, and 6 hours. I was testing this a lot, so I really never kept historical data there. But you can see this is very quick, just 4 lines typing into the shell, and you're already starting to drive these views, which are, again, just showing off of a REST endpoint. Now I'd like to show something with Hadoop. So let me go back to the shell here. There we go. So now what I'll do is I will create a new stream. This one is the Twitter stream, so it's not search, just literally all the raw contents of what's coming off of Twitter. And I'm going to pipe this into HDFS, and I'm going to roll over the files every 5 meg. So I'm going to create one of these streams. And if I pop into the browser of the file system here, by default it goes into the name of the stream. Oops. Where is it? What's going on? It should be Twitter stream. T-stream, yeah. Oh no. Let me see what's going on here. No, it's happy. Oh, I can do it in here. XD. Let me stop it and start it. So let me create it again. Oops. Hope it works this time. Go back into here. Yeah, OK. Yay. There it is. I don't know what was wrong there. So this is going to eventually grow and grow. It takes usually not that long. Now it's 0 bytes. It's rolling over every 5 meg. And now I will then go back and find my other command. Sorry. Oh, where is it? There it is. No, that's not it. Here we go. So I'm going to pipe this into a field value counter, and I'm going to peel off the entities that are the represented inside of a tweet. So you can have things like the stock symbol and hashtags. And in this case, I take the hashtags, and I'll take the text, and I'll put that into a counter name called hashtags. So now, if I look at field value counters list, I have the hashtags. I can do field value counter, display the name, hashtags, and you can see, view size, just 10. That's what we're starting to get in. So there's some Russian Cyrillic thing that's pretty popular. Retweet is pretty popular. iPhone games. Things that amaze foreigners. There's always something fun when you look at the real-time stream. And so this is what is going to feed in here, this tab here, what they call the garden hose. And that's basically showing that same counter, which is stored in Redis, and a small tag cloud. And you see it updating there. And there's, what language is that? Thai or something? And since all this is going into HDFS, let's see how that's doing. Probably a few files there, yep. So I'll go back here, stream list, and I'll just stream undeploy. This is tstream, just tstream. I'll just stop it. And now I've already coded up, actually Gunnar Hillert already coded up a MapReduce job, and it is called hashtag count. So I'm going to fire that guy up, and it's going to basically do the same thing. And what I wanted to show here is we have a new UI we're working on for SpringXD itself. This is really a revamp of the Spring Batch admin API at this point. So there should hopefully here come up the batch job that is running. If I go to single node mode, it says it. Oh yeah, I didn't trigger it, sorry. Let me trigger it. So I created it, it's waiting to be deployed. And this is a case where I can send a message now to the stream. Where is it? I typed so many more things than I anticipated. There we go. So now I'm going to use this trigger source to send a message to a channel that's associated with this job, hashtag count job, and it's going to launch the job. So if I look here, I see the job is running. If I go back to the new sort of UI, it should see hashtag count there. It started. And if I go back to this, just basically wait for it to finish. Can I have my note there? Thanks. I know it's a bit ironic we're waiting for a highly scalable MapReduce system to finish. There we go, 40%, 100%. So it's done. Oh, it's not done reducing yet. Let's wait for that. There we go. So it finished. So now if I do Hadoop, ls, file system, xd output, oops. There we go. So that's the file. What I'll do is Hadoop, copy to local, from there we go. So now that second picture here on the bottom is really the same thing, but came up from the historical analysis going over all the tweets. So there you have it. A few typos, but you can see the sort of power I guess it has in the shell. I can sort of recover and figure out where things are. So that's my saving grace for screwing that up a little bit. So if I go back to the slide here, what I'd like to show is one more thing, and then we're off to have drinks. It's a bit about the runtime support for SpringXD. So you define streams. These get passed into the XD admin server. The XD admin server is responsible for distributing it to different parts of the cluster. So you can have a cluster of machines. These are really just independent machines. And inside each one, an element of the stream will be, right now, sort of round-robined into each node in the cluster. And as many streams as you create, those different processing modules get distributed across each node. The communication, as Mark indicated on the edges of that diagram, are all pluggable. So you can have the communication between the nodes being Redis, Rabbit, pluggable. You can have it be sockets, JMS, anything you want that might be Kafka, whatever you might think is the middleware of choice for you to have communication between these components in your environment. And to help testing, you can have a simple single node environment where all the modules are running in one JVM, and then you can do very nice integration testing with them in order to discover bugs during your development before going to a full-blown distributed model. And so the simple cluster is really what we provide out of the box, namely you get servers, single node, and XD container, and you get the shell, and you can start them up, start up the middleware in case of a cluster, and you're responsible for maintaining it, basically. If one of those nodes go down, you should have some monitoring to bring it back up. But we've designed XD to be embeddable inside of other runtime environments. So for example, in the case of Yarn, there's already a resource manager in Yarn, which is part of the Apache Hadoop project, that's responsible for keeping up the different containers. If one fails, then it'll be restarted automatically, so you benefit from that resiliency. Same thing in the Yarn or the Hadoop platform. It will be able to scale out, and you can instantiate other containers as large as you need based on the size that you configured your Hadoop cluster to be. And we plan to support other runtime environments as we go forward, for example, Gemfire and Cloud Foundry and Amazon Web Services. And each one offers their own unique value proposition that enhances the basic foundation of what we have in terms of sort of the non-functional requirements, so the scalability, the reliability, and things like that. And so what I'll show here is a simple demo of having Spring XD run on Yarn. Yarn is a sort of big topic. It's really introduced a bit today in the blog post by Yana about the Spring Yarn project. And it's a part of Apache Hadoop that is really a rewrite of the first version of Hadoop so that you can not just run MapReduce as an application, but you can write your own custom applications and have them run on Hadoop. And so what I'll show is XD running on Hadoop. So I go back to the VM. What I have here is another instance of the shell, different version. And right now, oops. Just move my notes. There we go. So if I look in Hadoop, XD, I have an XD app.zip. That is basically Spring XD zipped up in a convention format so that it can be deployed on Yarn. If I do a Yarn list, oops, I can see the list of applications that are there. So this is the MapReduce job that I just launched earlier. And you can also see this if you go to the Hadoop cluster view, reload it. So that's the MapReduce job that I just ran before. So now what I'm going to do is I'm going to deploy XD itself onto Yarn, onto Hadoop. Let me go back to this guy. So it's a bit of a hack, but submit. And so I've now submitted, I hard-coded really in here, that it's XD app, this application. So it's accepted. And now you see I got this URL. This is the location of the XD admin port. So if I do server HTTP localhost 37979. There we go. So now I've connected the shell to the instance of XD that is running inside of Hadoop. And there should be no streams there, so I'll just create a simple stream. Definition, I'll just do time to log. And so now if I go look at the actual log files inside the Hadoop cluster, let me just see which one this is, 604. So if I go back to local logs, there we go. Go to my user logs here. Here's one of the containers. Here's one of the log files. And you'll see there's Spring XD running inside of Hadoop. That one probably got the time module. See, it launched in one container. So I launched two containers in this. I had that hard-coded. One of them is running the time source. If I go back out and then look at the other container, this one, oops, is running the receiving end, which is doing the printout of the time and doing it over and over and over and over again. So that's it. There's going to be a lot more to discuss about this at our session tomorrow, where we can dive into a lot more detail about what's going on under the covers, showing you how you can do much more sophisticated things other than the sort of linear flows. So getting started with Spring Data and Apache Hadoop, that's a good foundational talk early in the day. Then tackling big data complexity with Spring. And if you want to see some really cool UIs, go to the real-time analytics with Spring. Thank you very much, and enjoy the rest of the conference.